Imagine a time when nothing existed. No stars, no planets, no light, no darkness, because even darkness needs space to exist. About 13.8 billion years ago, the universe began. Not with an explosion in space, but with the expansion of space itself. This moment is called the Big Bang. Everything that exists today, galaxies, atoms, planets, life, was once compressed into an unimaginably small state, smaller than an atom, hotter than anything we can recreate. There was no before this moment. Time itself began here. Asking what happened before the Big Bang is like asking what lies north of the North Pole. The Big Bang was not a fireball exploding outward. There was no center. There was no edge. Every point in the universe expanded away from every other point at the same time. Space itself was being created. In the very first fraction of a second, known as Planck time, the universe was so small and so energetic that the laws of physics as we know them completely break down. Gravity, electromagnetism, and nuclear forces were all unified into a single unknown force. We do not yet understand this phase, and science openly admits that. A fraction of a second later, something extraordinary happened. The universe entered a phase called cosmic inflation. Space expanded faster than the speed of light, not because matter was moving quickly, but because space itself was stretching. In less than a blink of an eye, the universe grew from subatomic size to larger than entire galaxies. This rapid expansion smoothed the universe and created the basic structure we still see today. Tiny quantum fluctuations, random energy variations at the smallest scales, were stretched across the universe. These tiny ripples would later become galaxies, clusters, and vast cosmic filaments. As expansion slowed, energy transformed into matter. Particles began to form. Quarks, electrons, neutrinos, matter, and antimatter were created together. Normally, when they meet, they annihilate each other completely. But for reasons we still don't fully understand, the universe favored matter just slightly. For every billion antimatter particles, one extra matter particle survived. That single imbalance changed everything. Those surviving particles became all the matter in the universe today. Every star, every planet, every living being. Within the first second, quarks combined to form protons and neutrons. The universe was still incredibly hot, glowing with pure energy. About 3 minutes after the Big Bang, temperatures dropped enough for nuclear fusion to occur. Hydrogen nuclei formed, helium nuclei formed, tiny amounts of lithium appeared. These exact proportions still exist today and match our calculations perfectly. This is one of the strongest pieces of evidence for the Big Bang. But even now, atoms did not yet exist. Electrons were moving too fast to attach to nuclei. Light could not travel freely. The universe was filled with a glowing plasma, like the inside of a star. Then, about 380,000 years after the Big Bang, everything changed. The universe cooled enough for electrons to slow down. They combined with nuclei to form the first atoms. For the first time, light was able to travel freely through space. That ancient light still exists today, stretched into microwaves by the expansion of the universe. We call it the cosmic microwave background. It is the oldest light we can observe. The universe's baby picture. This light is almost perfectly uniform, but not completely. Tiny temperature differences appear across it. Those tiny differences became the seeds of all cosmic structure. After this moment, the universe entered a long, quiet phase known as the cosmic dark ages. There were no stars, no galaxies, no planets, only hydrogen gas, darkness, and gravity. For hundreds of millions of years, gravity slowly pulled matter together, silently shaping the universe. Eventually, the first stars were born. They were massive, extremely hot, and short-lived. Inside their cores, for the first time, heavy elements were created. Carbon dioxide, nitrogen, iron. When these stars died, they exploded as supernovae, spreading these elements across space. Every heavy element in your body was created inside a star. You are made of stellar remnants. Over time, stars grouped into galaxies. Galaxies formed clusters. Clusters connected through vast filaments of dark matter. The universe became a cosmic web. Dark matter, though invisible, provided the gravitational framework that allowed galaxies to form and remain stable. Billions of years passed. Stars were born and died. Planets formed. Chemistry grew complex. On at least one planet, matter became aware of itself. Then came a shocking discovery. Scientists expected the expansion of the universe to slow down. Instead, it is accelerating. Something unknown is pushing space apart. We call it dark energy. It makes up most of the universe, yet we do not know what it is. The future of the universe depends on it. Endless expansion, cold isolation, or something we have not yet imagined. From a quantum fluctuation to conscious thought, the universe has evolved. Every atom in your body has traveled for 13.8 billion years to be here, right now. The Big Bang was not the beginning of everything. It was the beginning of our observable story, and that story is still unfolding. Watching on Infinite Cosmos.